Hello everyone, I Shilpa K. Gowda, working as Associate Professor in EC Department. Today I am going to explain the experiment pulse amplitude modulation. So before we go with the experiment, first you should know that what do you mean by pulse amplitude modulation. In this modulation technique, the amplitude of the pulse in accordance with the amplitude of the instantaneous of the message signal. And also this modulation technique is used to convert the analog signal to a digital signal. And also you should know that what do you mean by sampling theorem. The sampling theorem states that a continuous time signal can be represented in its samples and can be recovered back when the sampling frequency is greater than or equals to twice the message signal. Next we will start with the experiment. The aim of the experiment is to design the PAM signal and also demodulate the PAM signal and verify the sampling process. So this is the circuit diagram of the pulse amplitude modulation. Here the transistor acts as the switch and we have given the message signal as a sine wave and the carrier signal as a square wave. So here the transistor acts as a switch. During the positive half cycle, the output of the transistor will be pulse, and during the negative half cycle, the output of this transistor will be 0. Therefore, you will get the waveform in this pattern. So this is the pulse amplitude modulation waveform. Next, this is the demodulation circuit. Demodulation circuit in the sense we have to get back the same message signal back. So here for this demodulation circuit, the output of the PAM is given as input for this demodulation circuit. In this demodulation circuit, we are using the low pass filter because the function of the low pass filter, it will pass only the low frequency signals. In this PAM circuit, we are using the message signal as a low frequency signal of 500 Hz. Therefore, we are using the low pass filter to pass only the low frequency signal. Therefore, we will get the demodulated output at the pin number 6. So this is the demodulated output. So for this demodulated output, we have to check the sampling equation, that is when fs is less than 2fm, greater than 2fm, as well as the equals to 2fm. So next, this is the circuit diagram connection of the PAM circuit. So first we have connected here the modulated output as well as the demodulated circuit. First we will check it here. We have given the input message signal. So we have given the input message signal as a sine wave. Next we have given the carrier signal as a square wave. Next we will check the modulated output, that is PAM output. So we got the PAM output here. That means here the transistor acts as a switch and we are getting the PAM output. Next, the same PAM output will be given as input for the demodulated circuit. Next, we will check the demodulated output at the pin number 6 of this op-amp. So we are getting the message signal back at this pin number 6. So after getting the output, next we have to verify the sampling process. That is, if the sampling frequency greater than 2fm, less than 2fm and equals to 2fm. To check that, first we will check it for the sampling frequency less than 2fm. So we will vary the frequency of this carrier signal here. So we'll keep it at 100 Hz and check that we are getting the waveform here. So what the waveform we have generated here, the same waveform we are getting, that is fs less than 2fm. Next we will check it for if the fs is equals to 2fm. So we are keeping this as 2fm. So next we are getting here, if the sampling frequency is greater than 2fm, we are getting the sine wave, that is the same modulated. The Viva questions for this experiment is, first one is what do you mean by PAM, what do you mean by sampling theorem, and what do you mean by Nyquist rate? Explain the working of both the modulation and demodulation circuit of a PAM. Thank you.